Now we are going to proceed to the derivative of sum and difference of functions. So again, let's review that if we have two functions, so let's say our function is u and v. So if we are going to find for so the derivative, so, so the derivative of u positive negative v with respect to x. So if our function goes like this, so positive, negative, or plus or minus, so anyway, we know that the sum and difference of any function, they are just in the same concept, but in terms of derivation, but with the main difference is about the operation. So with this, we know that to solve for so this is du with respect to x plus minus dv over dx. So if we're going to have this kind of example, so let's say if we have y is equals to um, 3x squared plus plus 5x minus 4. So at this point, this is already a combination of sum and difference. So first we are going to find for the first derivative or the dy dx. So okay, so we are deriving the function of y with respect to x because we are involving x. So now, so in order for this kind of so to understand this kind of theorem, that what we need to do is just separate them, in terms. So but when you derive this kind of function, what you need to do is just separate them or derive them separately. So each term you must derive them separately. So so let's derive first the first term, which is 3x squared. So this is under um, the constant multiple rule. So or automatic to, so just multiply them 2 times 3 or 3, and then let's derive the x squared. So this is 2x raised to 2 minus 1. So this is for the first term. Now let's proceed for the second term. So just separate the 5. Let's derive for dx. So the derivative of x. So okay, let's try this one. So this is x 1. So this, we have 1 here, x raised to 1 minus 1 minus, we know that any derivative of a constant, this is automatic as 0. So overall, if we are going to find our dy dx, we can say that, so 3, so this is 3 times 2x, yes, x, because 2 minus 1 is 1, plus 5x raised to 0. We know that x raised to any variable raised to 0, automatically is equals to 1. So overall, our y prime or our dy dx is equals to 6x plus 5. So this is our answer now. So next example, so if we have our example number 2, so let's say if we have w is equals to 5t squared plus 3t raised to 3 minus 5t. So now at this point, we are going to find for the w prime or the derivative of w with respect to t. Okay, so again, we have 3 terms again. So in order to solve this kind, so we need just, so we only need to derive them separately. So if you're going to solve for the derivative of w with respect to t, so first term, so let's separate the 5 and then derive the t raised to 3, no, t raised to 2. So this is bring down the exponent 2, copy the t, and then 2 minus 1 plus, let's separate the coefficient 3 and then bring down the 3, the exponent 3, copy the t, and then 3 minus 1 this is based on the, again, the exponent or power rule. So minus, let's separate the 5 times 1. We have exponent 1 here, and then times t times 1 minus 1. So this is our, so overall our dy dt is equals to this is 2 minus 1, this is 1, so this is 5 times 2 is 10, t raised to 2 minus 1 is 1, so that's it, plus 3 times 3, this is already 9, and then t raised to 3 minus 1 is 2, minus 5, t raised to 0 is 1. So automatic, our derivative or our w prime, or the dw with respect to t, or the derivative of w with respect to t, or our w prime, is equals to, let's arrange them, 9t squared plus 10t minus 5. So this is now our answer. Okay, now let's try some examples. So what if we have y, our third example. So if we have y is equals to let's say 2x raised to negative 1 half, and then plus 4x raised to negative 3 halves. So at this point, to solve for the derivative, so this is under the derivative of sum of the functions. So let's derive them separately, or it depends on you. So let's bring out the 2. Oh, let's separate the 2, coefficient 2, and then let's proceed to the, so the, again, the derivative of x raised to n with respect to x, or the derivative of y natin. So this is automatic n raised to x raised to n minus 1. So at this point, so let's move out the 2, and then bring down the exponent, negative 1 half times x raised to negative 1 half minus 1. Okay, and then we are going to use the same method. So for x, so let's separate the 4. Okay, sorry. So let's separate the 4. Let's bring down the exponent, 3 over 2, and then copy the x, then negative 3 over 2, the exponent, minus 1. Okay, so sa derivative of y with respect to x, this is 2, or we could cancel out this one, so we have negative, then x, so negative 1 half minus 1 is, and negative so negative x, so this is already negative x, so negative 1 half minus 1, this is negative 3 over 2, plus, so 4 times 3, this is 12 divided by 2, so this is we have 6, negative 6, so negative 6, and then x, so negative 3 minus 1 is, negative 3 over 2 minus 1 is, this is equals to 5, negative 5 over 2. Yeah, okay, so last step, so our dy dx is equals to negative x raised to negative 3 over 2 plus, okay, so this is not plus, this is minus 6x raised to negative 5 over 2. So this is our answer. Okay, now let's try so another examples. Example number 4. So what if we have function, or y is equals to 2t times the square root of t plus 1 over square root of t. Okay, so first we are going to simplify this kind of function or equation. So y, so we know that 2, so the t, if you're going to put the t in, or the t in the inside, so we could say that this is equals to t raised to uh, t times t raised to 2, right? Right? So that is, so for example, if we have the square root of t raised to 3, so we could be able uh, to transpose the one of the, so this is also equals to t times t raised to 2, and we know that the t squared can be, we can cancel the one of the t here, so this is equals to t over t the square root times the square root of t. So anyway, also if we have the, let's say if we have 8, oh no, we have 4 times 9. Okay, oh no, let's try some another example. So if we have 2 times 9, so for example, so we could be able to transpose this one. So this is because we know that this is 3 times 3, this is we could factor out the 3 square root of 2, so they are just equal. So in this kind of example, so we need first to in order to solve this one, before we start deriving this kind of equation, we need first to simplify this one. Thus, and then in my for me, I think we could be able to make this one into an exponent. So instead of division, we need this one. So we know that 1 over square root of 2, this is also equal to t raised to negative 1 half. Okay, so for me, the one of the easiest method is in terms of power rule. Okay, so y, so again, so this is 2 times the square root of this is t raised to 3. Okay, and then we know that the square root of x raised to 3, this is equals to okay, so the square root of x, we know that this is x raised to 1 half, because the exponent here is 1. So the square root of x raised to 3, so this is equals to x raised to 3 over 2. So if we have, so it depends on the exponent of the x inside the radical sign. So if we have x raised to 4 here, so we know that this is equals to x raised to 4 over 2, right? So at this point, so this is equals to, let's try this one, t raised to negative 1 half. So at this point, we can say that if we're going to simplify it more, this is 2 times t raised to 3 over 2 plus t raised to negative 1 half. So now we can be able to derive now uh, the each term. So the derivative of y with respect to x, this is now equal to, so let's move out or segregate the 2, then proceed to the, this is under the power rule. So bring down the exponent, which is 3 over 2, copy the t, then 3 over 2 minus 1, and then plus, so let's bring down the exponent, negative 1 over 2, then t raised to negative 1 half minus 1. So overall, if we find the dy dx, this is equals to, so the 2 here will be cancelled out, so we have only 3. This is 3 t raised to, so 2 halves minus 1 is, oh no, 3 halves minus 1 is equals to 1 half. This is 1 half plus negative 1 half, so this is already negative, so we could put negative here, negative 1 half t raised to, so negative 1 half minus 1 is negative 1 half minus 1 is equals to negative 3 over 2. So overall, our answer is, so this is already our answer. Or if you like it to be in terms of radical, so we could so dy dx, this is equals to 3, and we know that t raised to 1 half is also equal to square root of t minus, so negative 3 halves, so 1 half. This is the square root of t raised to negative 3. So the same also.